Assalamu alaikum, my dear student. How are you? I hope all of you are fine by the grace of Almighty Allah subhanahu wa ta'ala. I am Golam Mortuja and I am your physics teacher. Today I will discuss with you chapter 6, the effect of heat on matter. So dear student, give your full concentration on this class. Dear student, this is our first creative question. And here you can see that the stem is the length of a rod is 100 meter at 36.89 degrees Celsius temperature. Okay. Length becomes 100.033 meter at 66.89 degree Celsius. Okay. Student, number A question, here you can see that what is freezing point? Do you know what is freezing point? Okay, let me explain it. At standard pressure, the temperature at which ice starts to melt, that is called ice point or freezing point. Okay. And here, this is number B question. And here you can see that, what is the question? Why a gap is kept at the joining point of two rails of a rail line. Do you know why a gap is kept at the joining point of two rails of a rail line? Okay, let me explain it. Here you can see that the rail expands due to the heat of sun or due to the heat produced by the friction between wheels and rails when the train runs. Okay. For this expansion, sufficient space is kept the two rails so that the rail line does not bend due to its expansion, and we can prevent the accident. And for this reason, a gap is kept at the joining point of two rails of a rail line. I hope you understand. Dear student, here you can see that this is our number C question. And here you can see that the question is, what will be the reading in Fahrenheit scale when the temperature of rod is in normal temperature? That means I have to convert this Celsius scale to Fahrenheit scale. Okay. So here you can see that the given values are the temperature in Celsius Tc equals to 36.89 degree Celsius. Okay. And I have to find out the temperature in Fahrenheit scale. Okay. So I have to find out Tf equals to what? So my dear student, if I want to find out the temperature in Fahrenheit scale, then I know a relation between Celsius scale and Fahrenheit scale. Do you know what is the relation between these two scales? Okay, so now we know there is a relation between Celsius scale and Fahrenheit scale, and the relation is Tc by 5 equals to Tf minus 32 by 9. Okay, this is the temperature in Celsius scale and this is the temperature in Fahrenheit scale. Okay, so I know that the temperature in Celsius scale, the value of Tc equals to, here you can see that 36.89. So I can put 36.89 divided by 5 equals to Tf by minus 32 by 9. So if I solve this equation, then I can write 36.89 divided by 5 into 9. Okay, and Tf equals to 32. And if I solve this, then it will 5 into 9. So the value will be 66.402 equals to Tf minus 32. So if I want to find out Tf, then that Tf equals to 66.402 plus 32, and the value of Tf will be 98.402 Fahrenheit. So the temperature in Fahrenheit scale is 98.402 degree Fahrenheit. And I hope you understand how can we convert Celsius scale to Fahrenheit scale by using this equation. My dear student, number D question, here you can see that what is the stimulus bar made of? Analyze mathematically. That means I have to find out by which metal this rod is made of. Okay? So here you can see that if I want to find out by which metal this rod is made of, at first by using all of this given value, and I have to find out the coefficient of linear expansion, because to see the coefficient of linear expansion, I can say by which metal the bar is made of. Okay? So here you can see that the initial length of the rod is L1 equals to 100 meter, and the final length, here you can see that the final length L2 equals to 100.033 meter. Initial temperature T1 equals to 36.89 degree Celsius. Okay? At first I have to convert this degree Celsius to Kelvin, and if I want to convert this, then I have to add 273 with this value. Okay, so the value will be 36.89 plus 273 Kelvin equals to 309.89 Kelvin. And also here you can see that the final temperature is 66.89. That means T2 equals to 66.89 degrees Celsius. I need to convert also this value from degree Celsius to Kelvin scale. Okay, so if I add 273 with this value, then the value will be 339.89 Kelvin. And finally, I have to find out the coefficient of linear expansion for this rod, and alpha equals to what? Dear student, by using initial length, final length, initial temperature, final temperature, I have to find out the coefficient of linear expansion. And do you know what is the relation between all of these values? Okay, and here we know that the coefficient of linear expansion alpha equals to L2 minus L1 divided by L1 into T2 minus T1. Okay, so here if I put all of this value in this equation, then it will look like that. L2, that means the final length, 100.033 minus L1, the initial length, 100, and the initial length 100. The final temperature T2 is 339.89 minus the initial temperature T1 equals to 309.89. And if I put all of this value in my calculator, then I will get the value 1.1 into 10 to the power minus 5 per Kelvin. Okay, so here you can see that we got the value of the coefficient of linear expansion alpha equals to 1.1 into 10 to the power minus 5 per Kelvin. Okay, here you can see that we know that the coefficient of linear expansion of steel is 1.1 into 10 to the power minus 5 per Kelvin. And here the value of this part, the coefficient of linear expansion, is also 1.1 into 10 to the power minus 5 per Kelvin. So the coefficient of linear expansion of this bar is equal with the coefficient of linear expansion of steel, and that's why we can say that this bar is made of steel. Okay, I hope you understand how can we find out by which metal this bar is made of. So my dear student, this is our second creative question, and here you can see that the stem is a 200-meter long iron plates has been used on a railway line. There is a gap of 4 centimeters between two plates. Okay, the temperature increased 10 degrees above normal. Okay, and here the coefficient of linear expansion of iron is 11.5 into 10 to the power minus 6 per Kelvin. Okay, dear student, our A number question is, here you can see that write Hooke's law. Do you know what is Hooke's law? Here you can see that according to this law, within elastic limit, for any object, stress is directly proportional to strain. Okay, that means here you can see that stress is directly proportional to strain, and that is the Hooke's law. Okay, dear student, our number B question is, here you can see that a rotten egg floats on water but not a fresh egg. Explain it. That means a rotten egg floats on water but a fresh egg doesn't float on water. Okay, I have to explain it. Okay, so here you can see that the answer. Do you know, dear student, will the object float or not? This is totally depend on the density between object and the liquid. Okay, and here you can see that if the density of any object is higher than liquid, then this object will sink. Okay, but if the density of the object, of any object, is less than the liquid, then it will float. Okay, and here the density of rotten egg is less than the water, and that's why a rotten egg floats on water. But the density of fresh egg is higher than the liquid, that's why a fresh egg doesn't float in water. Okay, dear student, now I will solve number C question. Okay, and here you can see that the question is, determine the increased length of iron plate. Okay, so here you can see that at first I have to write all of this given value. Okay, and here you can see that at first the initial length of the iron plate is L1 equals to 200 meter. Okay, the increased temperature, here you can see that the increased temperature is 10 degrees Celsius. Okay, so increased temperature del T equals to, I can write T2 minus T1 equals to 10 degree Celsius or 10 Kelvin. Okay, and here you can see that also the coefficient of linear expansion of iron is alpha equals to 11.5 into 10 to the power minus 6 per Kelvin. Okay, and I have to find out the increased length of this iron plate. Okay, and here the increased length del L equals to, I can write L2 minus L1 equals to what? So dear student, how can I find the increased length? By using all of this formula. Do you know? Okay, let me explain. Dear student, we know that the coefficient of linear expansions equation. Okay, so by using the equation of the coefficient of linear expansion, we can easily find out the increased length. Okay, and so here you can see that we know that the coefficient of linear expansion alpha equals to L2 minus L1 divided by L1 T2 minus T1, or I can write L2 minus L1 is increased length and this is del L. Okay, and also I can write T2 minus T1, the increased temperature is del T. Okay, so alpha equals to del L by L1 into del T. So if I want to find out the value of increased length, I have to do cross multiplication. Okay, so here you can see that if I do cross multiplication, then del L equals to alpha L1 del T. If I put all of this value in this equation, and here you can see that alpha means the coefficient of linear expansion, alpha equals to 11.5 into 10 to the power minus 6, L1 equals to 200 meter, and also del T equals to 10. So I will get del L increased length 0.023 meter. Okay, that means that is the answer. Okay, so what is the increased length? We have got the increased length equals to 0.023 meter, and I hope you understand how can we solve this mathematical problem. Dear student, this is D number question. Okay, and here you can see that the question is, if the temperature increased by 15 degrees Celsius, will the train move safely? Analyze mathematically. Okay, so if I want to solve this math, at first I have to find out the increased length. Okay, so if I find out the increased length, then after that I can say that will the train move safely or not. Okay, so let's solve the math. And here you can see that the given values are at first the initial length of a iron plates. Okay, and here you can see that the initial length of iron plates L1 equals to 200 meter, and the increased temperature. Okay, here you can see that the increased temperature is 15 degrees Celsius, and I can write the increased temperature del T equals to T2 minus T1 equals to 15 degree Celsius or 15 Kelvin. Okay, and here you can see that the coefficient of linear expansion of iron is alpha equals to 11.5 into 10 to the power minus 6 per Kelvin. And I want to find out the increased length of iron plates. Okay, so I can write the increased length del L equals to L2 minus L1 equals to what? Okay, so my dear student, if I want to find out the increased length of iron plates, then how can I find out? Do you know? By using all of this value, I can find out the increased length because I know the equation of the coefficient of linear expansion. Okay, and by using this equation, I can easily find out the increased length of iron plates. Okay, and you can the coefficient of linear expansion alpha equals to L2 minus L1 divided by L1 into T2 minus T1, and L2 minus L1 is increased length, so I can write it as a del L. And here T2 minus T1 is the increased temperature, so I can write del T. So alpha equals to del L by L1 into del T. Okay, so if I want to find out this del 1, that means increased length, then I can do cross multiplication. Okay, and del L equals to alpha L1 del T. If I put all of this value in this equation, then it will look like that: alpha equals to 11.5 into 10 to the power minus 6 into L1. Here you can see that the initial length of this iron plates is 200 and the increased temperature del T equals to 15. Okay, if I put all of this value in my calculator, then I will get the value of del L equals to 0.0345 meter. Okay, and here you can see that the increased length of two iron plates is 0.0345 meter or 3.45 centimeter. If I want to convert this value from centimeter to meter, then I have to multiply 100 with that value and I will get 3.45 centimeter. Okay, and here you can see that the increased length is 3.45 centimeter, but there is a gap of 4 centimeter between two plates. Okay, so dear student, so each plate will increase by 3.45 centimeter, but here is a gap of 4 centimeter between two plates. Okay, so the train will move safely. Okay, and I hope you understand how can we find out will the train move safely or not by mathematically. My dear student, I hope you enjoyed the class and you have learned all of this creative question which I have already discussed with you. Inshallah, see you again. Assalamu alaikum, my dear student.